Hello everyone, we have here exponential equation 3 to the power of x minus 2 equals 4, and we're solving for the values of x. So let's start by writing the equation again. 3 to the power of x minus 2 equals 4. Interpreting the equation, what is the exponent of 3 to make it 4? So if we have here 3 to the power of 1, this is equal to 3. And 3 to the power of 2, or 3 squared, is 9. The right hand side is 4, so this means that the exponent must be closer to 1 than 2, right? So this must be 3 to the power of somewhere 1 point something, right? To make this equal to 4. So that's the interpretation of this exponential equation. And so how do we solve this exponential equation then, right? There are two ways to solve this exponential equation. First is to separate the constant out of the variable on the exponent, right? By using the exponent rules. And the other way to do it is by using the rules of logarithm, or the laws of logarithm. And so let's start with the first method. So here's the equation. 3 to the power of x minus 2 equals 4. So first method, we'll be using the rules of exponent, separating constant from the variable on the exponent. So we have 3 to the power of x times 3 to the power of negative 2. From the exponent formula, if we have here a to the power of m plus n, this is equivalent to a to the power of m times a to the power of n. We transform the left-hand side from this, the x minus 2 exponent. We separated them and became this one right here, 3 to the power of x times 3 to the power of negative 2. So we followed this formula. A here is 3, m is x, and n is 2. But since this is negative, we just write it as negative. And this is now equal to 4. Separating the constant out of the left-hand side of the equation, so we have to divide it by 3 to the power of negative 2 both sides, right? So we have this one cancelled. So we have 3 to the power of x is equal to 4 divided by 3 to the power of negative 2. And here we can put the denominator to the numerator, right? Since having a negative exponent implies that this can be moved to the top. So this is now equal to 4 times 3 to the power of positive 2. This is from the exponent formula. Say if we have 1 over a to the power of negative m, putting this denominator to the numerator, that will become a to the power of m. And this is now positive, from negative to positive. Likewise, if you have, let's say here, the numerator is a to the power of positive m, and you put that in the denominator, so we have 1 over a to the power of negative m. That's the same way, same principle. So back to our equation, so we have now 3 to the power of x is equal to the right hand side, that's 4 times 3 squared, and this is equal to 4 times 9, and 4 times 9 is 36. So we have 3 to the power of x is equal to 36. So now if you notice, the right hand side, can we convert this to base 3 as what we have here on the left hand side? There's no way we can convert this into base 3, right? So what we have to do now is use logarithm. So we take the logarithm on both sides of the equation now, or we can say natural logarithm. That will be the same way. We'll be using the log, or the common logarithm. So we take the log on both sides. So log of 3 to the power of x is equal to log of 36. And here we can take down the x now, the exponent, to the front. This is based on logarithm power rule. Let's say if we have log of a exponent x, we can take down the exponent to the front as a coefficient. This is now x times logarithm of a, or log of a. So here, we have x times logarithm of 3 equals logarithm of 36. Solving for x divided by log of 3, both sides. So this cancels. This is now equal to log 36 divided by log of 3, or this can be written the same way as log of 36 base 3. So this is the value of x. And now we're doing the second solution using logarithm right away from the start. Okay. Here's our equation. 3 to the power of x minus 2 equals 4. Now we do logarithms right away as a first step. So we take the log of both sides of the equation. So logarithm of 3 to the power of x minus 2 equals logarithm of 4. So here the exponent we can put down to the front, right? Like earlier, that's from the logarithm power rule. That is logarithm of a to the power of, let's say, x. Put down the x to the front. So this is now equal to x times the logarithm of a. So here we have x minus 2 times logarithm of 3 is equal to logarithm of 4. Dividing it with logarithm of 3 both sides. So this one cancels, so we have x minus 2 equals logarithm of 4 divided by logarithm of 3. And putting negative 2 to the right hand side, so we have x is equal to logarithm of 4 divided by logarithm of 3 plus 2. Or this can be written the same way also as x is equal to logarithm of 4 base 3 plus 2. That's the value of x. Now you might be asking, how come the value of x here in the second solution is different from the value of x from the first solution? From our first solution, we have the value of x here is equal to logarithm of 36 base 3. So that is x is equal to logarithm 36 base 3. That's our first answer. So our first value of x from earlier, so we have logarithm of 36 base 3. So we have the value of x. Now, so these are different, right? Wrong. These are the same, but it's just presented differently. If we use our calculator, we get the value of x on here or this here, we will yield the same result. So we have here the value of x by using our calculator. This is approximately equal to 3.26. That's the approximate and numerical value of x. And these two are the exact values. So now let's check our answer to verify our value of x, right? And so to check our answer, we have this original equation that we have, and we're plugging in the value of x that we found. That's approximately 3.26 to the exponent x right there, right? So let's do that. So we have here 3 to the power of x minus 2, 3.26 minus 2, and will this be equal to 4? So 3 to the power of, subtracting 2 out of this, will be 1.26, and 3 to the power of 126 is equal to approximately 3.99, and this is approximately equal to 4. So they'll be really close enough. So this simply means that the value of x that we found is correct. All right. Thanks for watching. Have a great day, everyone. Bye. Take care.